All right, so in this video, we are looking at extraneous solutions. And extraneous solutions are solutions that we get sort of as an artifact of the mathematics we're doing in order to solve some of these radical equations. But what happens is after we get these solutions, we then go back through and solve them. And we then, in fact, discover that we do not have a solution where it looked like we did, in fact, have a solution. And we'll also look at a couple of the examples of where this is going to occur. So you might be able to sort of have a hint of, okay, it looks like we're going to have an extraneous solution in this particular example. So the example we're looking at first is that x is equal to the square root of x plus 6. And the square root of x plus 6, we look at this and we say, well, we can't really combine x with the square root of x plus 6. So our first step in this example really has to be to square both sides. So I'm going to begin by squaring both sides of my equation. X squared is just x to the second is just x squared. And when we square the square root of x plus 6, we're left with x plus 6. And I look at this and I say, all right, well, unfortunately, we can't directly solve for x in this because we have an x squared term and an x. And if you remember, that means we're going to have to do another solution method. So I'm going to go ahead and I'm going to subtract everything over to the left side here. And we're going to have x squared minus x minus 6 is equal to 0. Now from here, you have a few different ways you can go to solve this. I'm going to do this by factoring. The other way you can also do this is you could actually apply the the quadratic equation, but I think that factoring is probably going to ultimately be the faster way to go. So on this thing, we got to think about, all right, a times c, a is 1 because that's the thing attached to x squared, implied to be at least, and negative 6. So our a times c is negative 6. Our b value is, that's the negative sign there, so it's a negative 1. I need to think of two numbers which multiply to negative 6 and add to negative 1. Those two numbers are, of course, 2 and negative 3. 2 times negative 3 is negative 6. 2 minus 3 is negative 1. So we now get to split up x squared into 2x minus 3x. Note that 2x minus 3x equals negative x minus 6. From here, we get to factor each part. This one shares only an x, so we're able to pull x, and then we have x plus 2 left. And the second part, it shares a negative 3, so I get to divide those out. And negative 3x divided by negative 3 is x, and negative 6 divided by negative 3 is plus 2. And this still all equals 0. So at this point, I'm now able to rewrite this as a product of factors. My first factor is the x plus 2. My second factor is x minus 3. Finally, we get to solve for our values of x equals 2 and x minus 3 by setting them each equal to 0. So x equals negative 2. Whoops, can't see that right now. It's the first factor. And our second one, we add 3, and we end up with x is equal to 3. So we have these two solutions here at the end, x equals negative 2 and x equals 3. And as you recall, our original prompt was x is equal to the square root of x plus 6. And at this point, we need to figure out which one of our two solutions is extraneous. We're going to have extraneous solutions in each of our problems in this video. And let's look at our first one. We're going to start with 3. And we need to plug in this 3 down here for x. So this x is now a 3. And underneath our square root, we have 3 plus 6. Some of you may have already even seen the solution already. And you say, oh, well, the 3 plus 6 is 9. All right, cool. And 3 is the square root of 9. So this checks out. We're good here. Well, by process of elimination, obviously negative 2 is going to end up being our extraneous solution. But let's check out what happens when we plug in negative 2 for x. All right, we have negative 2 equals the square root of negative 2 plus 6. At this point, you should already be thinking something is terribly wrong. Because if we add negative 2 to 6, we get the square root of 4. And the square root of 4 is 2. Square root of 4 is not negative 2. And in truth, you should have noticed something was wrong in the very first step, because the very first step is asking you to say, all right, if I plug in -2 into this equation, I'm saying that -2 equals the square root of something. The square root of something is not going to come out to be -2. You don't get negative numbers out of square roots, at least not when we're working with real numbers. So right there, you should have said, all right, -2 is going to be a problem. That doesn't necessarily mean that a negative number will never be a solution to one of these, but you can bet that there will be times when it'll happen. For example, if we had instead had a negative x sitting out here instead of a positive x, that would have meant that the -2 would have been our solution rather than the +3. And if you'd like to check, you can go back and take a look at that. But you might be asking yourself, where did this extraneous solution get introduced to this problem anyway? And the problem is up here when we square both sides. When we square both sides, that gives us x squared. Originally, this x in the problem is just a regular x, meaning it can be positive or negative. But once it becomes an x squared, every time you square that value in the x, it becomes a positive number. And that's the issue that comes in down here, is that positive number or negative option that the parabola introduces, or the squared term introduces, essentially gives us two possible solutions to the parabola that we ended up in the step right here. And that ends up giving us two solutions when there really only should have been one. So squaring it is what caused the trouble on this one. Unfortunately, there was no way to really get around that, and you really just had to go through and check the solutions at the end. Now, in another problem, we're going to see a different type of issue that can occur, and we're going to find an extraneous solution and see what happened. So in this next problem, this will be our second example, we have 13 plus the square root of 5n equals 3. And this one, you're probably going to look at it and say, oh, this one's really similar to the ones we did in the last video. So I need to isolate the square root of 5n first. So I'm going to subtract 13 from both sides. All right, that's fine. And that gives us the square root of 5n is equal to -10. And then in order to get into our 5n, we got to square both sides. All right, this is all pretty normal. Got to square -10. The square root of 5n squared is just 5n. -10 squared, and negative times negative is a positive, giving us 100. And then finally, we divide by 5, and we get n equals 20. And on this problem, you might be thinking, oh, well, perfect. That was pretty straightforward. We got n equals 20. What could possibly go wrong with this? And I'd say, well, let's take a look at what we can plug in for n, and let's see what happens. So let's go ahead and plug in 20 for n in our original equation. So we now have 5, and where we previously had n, we have 20 again. And it all equals 3. So 5 times 20, maybe you need to grab your calculator for this one. I've seen it enough times that I know that 5 times 20 is 100. And 100 is another of our perfect squares because 10 times 10 is 100. So that means that the square root of 100 is 10. And we have 13 plus 10. 23 is equal to 3. That is not the case. And that consequently means that n equals 20 is not a solution to this. And in this one, once again, what's happened is squaring has got us into a little bit of trouble. And the issue comes after we subtract the 13 from both sides, and we get the square root of 5n is equal to -10. When we square both sides right here, the negative in the -10 goes away. But that -10 was actually really critical, because initially what this is asking us is what number n do we multiply 5 by, and then when we take the square root of that, we get -10. Just like the previous problem, when we ended up right here and we had -2 equals the square root of 4, that is not something you can get out of the square root. You only get positive numbers out of the square root. So trying to get a negative is a fool's errand. Again, at least until you get into algebra 2. So that means that at this point right here, you actually could have just stopped without squaring it and said, the square root of 5n does not equal -10, because I'm not going to get an n value, which is going to satisfy this equation. So as it turns out, whereas this problem up here presented two solutions, but only ended up having the one, this problem presents one solution and doesn't even have that. So that's a tricky part of radical equations. Sometimes you're not going to end up getting any solutions for them at all. All right, so that covers our extraneous solutions, and you'll want to watch out for primarily when we end up squaring negative numbers. That's one thing that can happen that can introduce an extraneous solution, or potentially when we square a variable and get the squared version of it, like what happened at the very beginning of this problem when we got that x squared. So when you see one of these radicals, be cautious of getting two solutions and make sure you go back and check them, and check every time you square a negative number, because that can also get you into trouble.